Good day, McVeigh, and happy Friday once again. We have a quick show this morning. Come on over. We have a big project coming in first, Miss Minerva. Look this, what we have here. Okay, so I'm going to let all of you introduce yourselves. I'll get out of the way. Okay, so we have
Assad, Tyler, Oscar, Annika, Jack, Ryan.
Okay, so what do we have this morning?
We have electricity.
Electricity. Now, you guys had been here related to thunder, correct?
Yes.
Okay, so what about electricity?
Lucas was a bat. If you touch electricity, you will get shot. The force of electricity is more than 9,098 times the force of a
Major league.
major
Yeah, so what he just said is that the force of electricity is strong, so that if a major league pitcher threw a ball at you, Mr. Minerva, the force of electricity is 9,800 times that. So pretty strong, don't you think?
I think the Yankees could use that kind of power.
Oh, yes, I think many clubs could use that kind of power. Okay, so why did you choose to study electricity? What do you think? You like electricity? Well, I do. Why do you think I like it?
Because it's how our phones, iPads, and TVs are able to work.
It's how everything works. You know, there's a community of people in the world that really do not use electricity whatsoever. Do you know what community of people that is?
Africa, maybe?
Well,
They don't have a lot of phones there.
that's true. They don't have a lot of phones in Africa. So that's not by choice. So this would be a choice people are making to not use electricity. Do you know who those people are? There's a group in Pennsylvania, upstate New York, Ohio, Florida. Yeah.
Farmers?
Okay, they are farmers. I'm going to tell you because we don't know. They are the Amish. Some people will say Amish. So these are people that decide not to use electricity. We do use electricity. So what are all these pictures, Annika?
Pictures of electricity.
Okay. So, but these, you know what these are, Ryan?
They're the way our phones are powered.
Do you know what those are?
Windows?
Close. They look like windmills. There's a certain name for
I know
those.
where all those are.
What are they?
They're like, sometimes you see them at Jordan Beach, but if you go to Hungary, there's a huge field of all of them.
Yeah, what are they called?
I don't know.
Do you know what they're called?
No.
How about you? Okay, good. When you don't know something, it's good to say you don't. So it's called a turbine. Those are wind turbines, and what happens is, kind of like a windmill, the wind hits the propellers, and they spin, and their action creates an electrical current that can power our houses and so on. And so they make them in fields, and this would be a field, so there's many of them there. And they put them in windy places to get power from the earth, right? Okay, so what else do you want to tell us about electricity? Anything? Who discovered electricity?
We're not sure.
Oh,
Thomas Edison.
let's put it out there.
Oh, he already
It's
said
not
that.
Thomas Edison.
By the way, before you had answered turbine, someone in Mr. Chanfos' class had chimed in wind turbines.
Oh, I'm
So they
so
were
glad
aware
to
of
hear
it.
that somebody's paying attention. Okay, so who discovered electricity? Let's put that out. It was not Thomas Edison. Okay, so do you want to say something else, Ryan? What do you got?
Electricity, all shapes and sizes, can be very powerful.
Yeah, electricity is very powerful. Yep.
Electricity can travel more than 1,000.
Ooh, more than one. How many thousands are there?
186,000.
There are 186,000 there.
And seconds.
Handily, yes.
A whole line can measure up to 3 million volts, and it lasts less than a second.
Yeah, so electricity travels 186,000 miles, right? Okay, place value. It's all about place value.
All about the place
It's all
value.
about place value. Yeah.
Also,
electricity can shock you if you're not careful.
Yeah, you have to be very careful. That's why they make those safety plugs for little children. All right, high five. We're going to get some answers. I have to go on to binary code. Binary code is coming up next, I think. High five. All right. Thank you, guys. All right, so there he is. Binary code. Come on down. All right. So tell us about binary code, Ryan.
So binary code is basically computer language.
Yes. So why did you just decide to do a project on computer language?
Because my dad is a computer scientist, and
Oh.
I thought, why not just try and do it better?
Very good. So have you created some binary code?
No, not yet.
Okay. So
just
tell
read
us
about
about what you wrote here.
So binary code is computer language that is made out of ones and zeros.
That's true.
Binary code uses base 2 instead of base 10. Base 10 counts by tens, and then base 2 counts it times the number by 2.
By two. That's correct.
And both of these bases, they always start with 1. So over here, I put a place value of base 2. It can keep on going on, and it starts from 1, then to 2, then 4, then 8, then 16, then 32, and so on.
Because you're multiplying by
2.
two. Correct.
So binary code would be 1 would be activated and 0 would be unactivated. Well,
Inactive.
yeah,
Yeah.
inactive. And since over here I put the number 10,
Yeah.
since the 2 over here is activated, 1 here is not activated. This 2 place value is activated. The 4 place value is not activated, and then the 8th place value is activated. So then you add 8 plus 2, and then you get 10. So then letters in binary are simple, now that you know the numbers. The letters are kind of simple. There are 8 numbers in a binary letter. The first 3 is whether it is an uppercase letter or a lowercase letter. 1 0 is or 0 1 0 is uppercase letter. It would be like an uppercase letter, and then 1 1, you could also write it as 0 1 1 to make it easier, is lowercase. So then the rest is where the letter is in the alphabet. So then over here I put like some of the alphabet over here in binary. So A would be 0, a capital A would be 0 1 0 0 0 0 0 1.
And a lowercase would be?
0 1 1 0 0 0 0 1.
Correct.
And then a capital B would be 0 1 0 0 0 0 1 0. Because A, it's the first letter of the alphabet, and 1 is right over here. So then a 1 will go over here, and then the first 3 would be if it was So
you can see, this is very complicated. I don't know that everybody is understanding what he's talking about, but you can take a look at his poster and you can see what he's done is given us the code for the letters based upon it being either uppercase or lowercase. So the 0 1 0 is an uppercase, and the 0 1 1 is lowercase. Okay, and then the end digits will indicate which letter it is. All right, so this is highly complex. What do you use binary code for?
you would use it to make websites. You would use it to make software. You would use a lot of stuff for it.
Yes, and
computers.
Can there be additional code, binary code created?
I think so,
Yeah.
because I think that this is only the beginning.
Yes, only the beginning. That's correct. All right, very good. This is only the beginning, but those boys and girls who have played McVeigh the game have actually used a game that was created from binary code from scratch, sort of a easier version of this, would you say? But it's all the same thing. It's all based from this. And many of our children are learning how to use it. So good job. I would love for you to come back on and let's have another discussion about this, but when I have more time. How does that sound?
Okay.
Okay, so we have to get the spelling bee started today.
Okay.
All right, high five. Really good stuff. Okay, and the last project today, Jenny and Caitlin, come on down. All right. So this is a cool one. Well, they're all cool, I have to say. All right, so Jenny and Caitlin, what do you have here? This very unique project. What do you have here?
McVeigh history.
The history of McVeigh. Well, we wish we'd had this like years ago. Nobody thought to do this. So what did you learn about McVeigh?
That it has many activities. It's a good school. And there's
You had
I
to
thought
read
you
that?
knew that. Yeah. So what was the original name of McVeigh? Meadowlawn School. That's correct. And do you know what year McVeigh was opened in?
1953.
1950. Yeah, 50 something. Okay, we'll put that out there. Okay, and who was the first principal at McVeigh? It wasn't me. Does anybody know the first principal of McVeigh? Let's put it up a little higher.
Put it
Who's
out there.
that guy?
That's George H. McVeigh.
Yes, and that's the man that our school was named after. Who was he though?
It was a school executive.
He was. What did he do for East Meadow Schools? What does it say there?
It doesn't say.
Oh, so we're gonna have to do some more work on this. We want to know what year McVeigh had their first year of school. We want to know who George C. McVeigh was. And what was the other question I have? Did I have another one?
What year was it?
What year?
Yeah, what year?
And I believe all that information can be found in the building if people
It can. So let's see if somebody can go on a scavenger hunt and figure that out. Okay. Anything else you learned? We learned about some of our clubs and so on. I see that you have pictures of Mr. Minerva and me on there. Awesome.
Yes.
And we have many of our teachers, right? So those are the current teachers, correct? All right. So did you have fun doing this project about McVeigh?
Yeah.
All right. So we need some more information, though. You think you can get it for us and get it back to us?
Yes.
Yeah? What is that big heart for?
Because we love McVeigh.
Because you love McVeigh. And they love him too.
Who doesn't love George McVeigh?
Who doesn't love George McVeigh? Our school's named after him. All right. Good work, my friends. All right. And you're going to come back with more
By the
information,
way,
correct?
in Miss Gallery's class, Dia Singh says 1950 was the year.
1950. That's correct. It was 1950, not 1953. That's correct. Thank you, Dia Singh. All right. So we're about ready because we have to get our spelling bee started today. So girls, if you could just step to the side, we'll have our mighty kind, mighty find. Dun, dun, dun. We have to get a nice big. Oh, look at this one. This is coming from Megan. And I am assuming this is Megan Kemmler, 218. It has to be Megan Kemmler.
Mm-hmm.
So here it is. You ready? Never be afraid to spread kindness because it could travel the world. So I think that's kind of like our bulletin board, kindness is contagious. So what it means is that when you spread kindness, it makes other people want to be kind and then pass it on to others. So your kindness could wind up affecting somebody else in another country, maybe even another continent, maybe even Africa.
It can be
Right?
many people all
Many,
over.
many people, even those that don't have electricity. Right? Okay. All right, boys and girls, we want to wish our spelling bee participants a wonderful bee. Good luck to all of you. And of course, boys and girls, every day is a good day to get smart and be kind to both each other and the earth. Let's have a wonderful day.